everybody, I hope you're doing well and welcome to the platform of CodeChef. So today we'll be going to solving the problem polite numbers. The difficulty level for this problem is simple and the prerequisites required are just basic observations. This is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, so now let me just summarize what a problem statement is saying. So basically, for any number, say it is said to be a polite number if and only if it can be represented in the form of sum of two or more consecutive integers. So it has to be in the form of such a way such as a plus 1, or I have a plus 1 plus a plus 2, or similarly, so a plus 1 a plus 2 and so on. If it can be represented any in form of any two or more consecutive integers, then it's my polite number. So as you can see in the example also, my 7 can be represented as 3 plus 4 and my 3 and 4 are consecutive integers. Similarly, my 15 can be represented as 4 plus 5 plus 6 and those are consecutive integers. So these numbers are polite numbers. In the question, we are given a positive integer n, and we are told to find how many positive integers from 1 to n are not polite. So basically, we have to find how many integers from 1 to n which are not polite or which do not satisfy this particular condition. And let me just have a look at the constraints also. So in constraints, my n is 10 power 18. So generally, whenever you're given constraints of n around 10 power 18, for each test case, you should know that the expected time complexity of this question is around O of 1 or O of log n. So always when you're forming your approach, you should think about this time complexity. Now let's see how we can approach this particular problem. Okay, now to understand the approach for this particular number, let us look at some basic observation. I have generated my 1 to 17 as sum of consecutive numbers. So firstly, my 1 is not a polite number because my 1 cannot be represented as sum of two or more positive consecutive integers. So that's why I put across. Similarly, my 2 is also not a polite number. Then I see my 3 is a polite number which is 1 plus 2. My 4 is not a polite number. My 5 is a polite number which is 2 plus 3. My 6 is a polite number which is 1 plus 2 plus 3. 7 is a polite number which is 3 plus 4. 8 is not a polite number. 9 is a polite number which is 4 plus 5. Similarly, my 10 is 1 plus 2 plus 3 plus 4. And so on. As you can see, for every particular number, I have written the sum of consecutive integers which make up to that particular number. So here one very important observation lies. Let's look at the numbers which are not polite and which is required in this question. As you can see, this number which is my 1, this number which is my 2, this is my 4, this is my 8 and this is my 16. So as you can see, any number which is written in the form of 2 power k is not polite, and yes, this is the observation for this particular question. So what I can do is for n, any generalized n, I can find out how many powers of 2 exist which are not polite. So yeah, how many numbers of 2 exist between this 1 and those numbers will not be polite. And for that, the answer is nothing but my log of n plus 1 with the base 2. Okay, let me just write it clearly. So my answer for that is log of n to the base 2 plus 1. And yes, our approach for this problem becomes simple as that. So for each test case, the n I input, the answer or the number of non-polite numbers is just log of n plus 1. Yes, we can easily achieve this by logarithmic complexity and our solution will be O of log n, which will pass for each test case, and yes, this becomes the correct approach. Now let's see how we can code this particular problem. Okay, now let's try to understand the code for the following problem. So firstly, we included all the header fields necessary. Then we included all the variables and initialized the required variable. Then for three test cases, we simply inputted our n. Our answer is nothing but log n to the base 2 plus 1 as we discussed in the approach section, and then we printed our answer for each test case. Now let us see whether our approach works on the sample test cases. So as you can see, we got the correct answer for the sample test cases. Now let us submit our code and the actual test cases and see whether everything is working correctly or not. So as you can see, we got the correct answer for this problem and this becomes a valid approach. Now let me show you the Python implementation as well. So for the Python implementation, we did the same thing. We just took the answer as log 2 to the n, log n to the base 2 plus 1, and we printed our answer for each test case. And the log we are using math library. So yeah, this becomes the approach for this test case for this particular problem, and let me show you one of the solutions where people could go wrong in this particular problem. So as you can see, this person received a time limit exceeded verdict, and that was because this person wrote a brute force approach from n to 0. So this is the big O of n approach, and since our n in the constraints was 10 power 18, that's why this person received a time limit exceeded error. So firstly, whatever code you are writing, you should be take care what are the constraints and what is the required time complexity for the code. So yeah, I hope you like this video. Please like, share and subscribe to our channel. Thank you.